Okay, I'm started recording. So, okay, data structures means when I was explaining collections, right?
Yeah.
Array list I explained, correct? After that, linked list I explained, correct?
Yes.
Array list elements will be saved. I mean, in an array, correct? It will
Yes.
inside the backend. Okay.
Yeah. Yeah.
But whereas linked list, right? Each element, whenever you are adding one element, so what it will do, it will create a node basically like this. One node like this. So node means, so this is a node. So you see three parts,
Yes.
correct? Okay, the middle part is data.
Yeah.
So whatever linked list you are trying to, you will create a list equal to list L equal to new linked list and L dot add, you will add one element, correct?
Yeah.
So what it will do, so whatever data you are trying to add, it will be saved in middle box, I can say indirectly. This is called as a node basically. First of all,
Okay. Node.
this entire section is a node, and
Yeah.
this node is having three parts.
Okay.
The middle part is containing data,
Yeah.
and the left side left side and right side, leftmost and rightmost, I mean portions is having memory locations.
Okay.
So what is which memory location it will be saved? Okay, say for instance, first element you added, and the data will be saved in the middle part. Okay.
Yeah.
Say for instance, now you are trying to add second element. So it will create second node, and data will be saved here. Okay.
Yeah.
So when you are adding first element, right? So this is also having some memory, correct? It should be saved somewhere, right? In the hard disk,
Okay.
in the RAM or somewhere, right? So
Yeah.
in that type, so where the second element got saved, meaning this memory location will be saved here. Got it, right? So second element, it should save somewhere, right? Mustafa?
Yeah.
Yeah, the second element should save somewhere. So that memory location we are saving into the right rightmost portion. So we
Portion.
are saving this memory location here. Okay.
Yeah. Yeah.
And you are going to add third element.
Yeah.
So data will be there here, and it should save somewhere, right? So this memory location will be saved here.
Yeah.
It is like a train, how they are linking.
Yeah. Yeah. Is linking from back into forward actually.
Correct. So if you know this location, this memory location,
Yeah.
then you can able to navigate, right?
Yeah.
So this is one of the example for linked list.
Yeah.
In the similar way, I told, right? Another example I was explained when I was explaining um, exception handling. I
Exception hand.
Yes, I explained stack.
Yeah.
Correct, like a biscuit packet. Some example I had given, right?
Yeah.
So meaning stack meaning it is a kind of small kind of box which is having only one side opened. So whenever we are adding elements, so first element, second element, third element, fourth element, fifth. Okay, correct. So this is the first and second and third and fourth, fifth, correct.
Yeah.
So you added five elements. This is
Yeah.
the addition order, correct.
Yeah.
So whenever you are trying to remove the elements, how you are going to remove it in this case?
Okay.
So we have to remove last in first out, correct?
Okay.
So this is the first added element, but you are not able to remove this one, right? First.
Yeah.
So you have to remove the last in first out.
First out.
This is called stack.
Tech. Okay.
Okay. So this is a double linked list. And the similar way we have single linked list also.
Okay.
So this is a double linked list. Did you see
Yeah.
this one? Okay.
Yeah. Yeah.
And this is a stack.
Check. Okay.
Okay. And there is another one is queue.
Yeah.
Queue means if you see, if you're standing at any place like a ticket counter or ATM center,
Okay.
so whoever will come first, they will be processed, right?
Yeah. First in,
Yes.
first out.
Yes, first in, first out. So that is called queue.
Queue.
And whereas in case of a stack,
Last in, first out.
yes, last in, first out. So that is the difference between stack and queue.
Queue. Okay.
It's clear, right? Stack
Yeah.
is clear,
Yeah.
queue is clear,
Yeah.
and double linked list is clear, right?
Yeah.
And if you say in real-time example where it will be used, printer is using this concept
Okay.
queue. Why? Because say for instance, in office generally they will keep one printer, right? They will not keep a printer for everyone, correct?
Right.
So they will keep one printer and everybody should use the same printer, correct?
Right.
Okay. So the printer means so many people are giving firing print, right?
Right.
So which one? So whoever is firing print first, so they will get their printout,
Yes.
correct? So printer is using this concept. So real-time example I can say indirectly. So whoever is firing the printer. So what printer will do? It will take all the request, but it cannot. It is not able to print all the prints one time, right?
Right.
So what it will do? It will take all the prints and it will keep in the queue.
Yeah.
Then it will start executing.
Yes.
So whatever request came first, it will process that one. Like that, slowly it will process from first in, first out.
Right.
So that is the concept called uh, queue.
Queue. Right.
Okay,
Yeah.
and sorry, and the stack example is um, okay. If you see stack example, we can give two examples. One is first word. Take simple example. So whenever you are typing, right, I'm typing like this: 1, 2, 3, 4, 5. Correct?
Yeah.
I typed some words, right? 1, 2, 3, 4, 5. If I press Control Z, which word will be removed?
First one. The last one.
First, I had to save this one basically. Then we can see the difference.
Yeah.
So now I did some typing and I saved it. When I press Control Z, right? Did you see this?
Yeah. The last one. First out.
So last in, first out.
Yeah.
Correct?
Yeah.
Last in, first out here. Do you
Yeah.
see this? So operating system will use this concept.
Okay.
So whatever you typed last, so that will be removed, correct?
Okay. Yeah.
So operating system also, so whenever you are typing something, whenever you did save, right?
Yeah.
So what it will do, it is also maintaining internally one stack. So
Right.
whenever you are pressing Control S, so it will dump something into the stack.
Yeah.
So this is only for temporary purpose. If user is trying to press Control Z, then it will remove the last portion.
Right.
It will remove the last portion. The remaining portions will be there as it is.
Yeah.
So operating system will use this stack concept. It is clear, right? This one.
Yeah. Yeah.
So whenever you are pressing Control Z, so it will be the last type things will be removed. So this is one of the example for stack.
Yeah.
Okay, now and another example I can give you. Another example, right? So whenever you are writing a simple Java program, so what you will do, you will write first, you will write a simple class test. Inside that you will write main program, correct?
Yeah.
So from the main program, you will call another method, another class method or same class method, correct?
Yeah.
So how the execution will be happening? So first it will start main, but it will not complete main method 100%, correct?
Yeah.
So it will not complete main method 100%. I will show you. So this is another example for stack. All these things are basically like data structures. At least you should be in a position to explain theoretically. Why? Because these are I explained so far. Everything is theoretically correct.
Yeah. Yeah.
So we can able to write programs for all those things. Like we can write a simple Java class, and we can able to give the elements as a inputs. And when we are trying to read it, so we should give the elements in that order. So this is theoretically what I'm telling. Similarly, we have to write programs for this one. So this is called as a Java program.
So data structure actually have a different chapter, no? Because data types, primitive, whatever else is
No,
there.
no, that is data types only. This is also it is kind of general problems and predefined problems and solutions.
Okay.
If you are going, you like you you are going as a developer, right?
Actually, this is kind of like these things. They actually want someone who can work as actually lead of testing, but his main function will be the Java. So they actually tell me that they want something else who can very deep knowledge on Java, and
Uh-huh.
then he have to meet so many people's on offshore and onshore.
Okay.
Yeah. So then he gives some simple question. The recruiter that I send you the question, you got it. I think
Yeah, I got your message just now. I saw it. Yeah. Mm.
So I was actually preparing myself. He mentioned this is core Java
Mm.
collection and data structure.
Mm-hmm.
Those three things actually that will be more focusing on the interview.
Maybe they will ask algorithms also. Algorithms.
Yeah.
Algorithms. I don't know. Maybe design patterns. There are so many things. It is kind of for a developer. When they will ask these kind of questions.
Yeah, I think they will go going for more deeper maybe.
Yes, yes, yes. Okay. First, we will see this example. After that,
Okay.
stack. One more example I'm giving for stack.
Yeah.
So one example is this typing. Correct. So if you see another example, I'll give. So now we have this word, right? I typed, right, this one. I only did typing, right? So I mean, I draw these pictures, correct?
Yeah.
So when I press Control Z, which one will be removed first?
Uh,
See
uh,
this?
last one.
Yes.
Last.
See last one, correct? For recently I explained this box, correct?
Yeah.
So when I'm pressing right, it is removing. When I'm adding, when I Control Z, Control Y, so again it will come back, correct?
Yeah.
So when I press Control Z, it will be removed the last whatever ID type. When I press Control Y,
And it's come back.
recently whatever I type, it will come back.
Yeah.
So this is also a kind of stack, correct?
Yeah.
So uh, operating system also will use this concept.
Okay.
So this is another example, basically, I can say indirectly. Okay, now come back to our Java program. So first, whenever you are executing this program, which method will be executed?
Main.
Main, but it will not say, for instance, I'm calling here. This is very important. Basically, if you go for 10 years of interview, so they will ask this kind of questions. So if you can able to tell in a real-time way, they will not ask any questions.
Okay, yeah, that's fine.
If you're going as a developer, like a lead or architect role, they will ask in depth what is data structures, and they will not ask theoretically. They will ask programmatically where you are using this one. Do you see anywhere this usage in real time? So then you should be in a position to say, I saw this kind of implementation in our operating system in this particular way. It will work. Then they will understand. Yeah, this guy is having some knowledge, so you can able to differentiate real time way how it can be used. So then they will not ask much questions. Okay, now I am going to call method 1. After that I am going to call method 2.
Okay.
So just I have written some 3 methods, correct?
Yeah.
I need to provide some implementation for these methods. So now let me create method 1. Let me create method 2, method 3. So 3 methods I have created, correct?
Yeah.
Yes, 3 methods. This is also one more example for stack.
Ah,
Okay, first, right, when I'm trying to execute, first which one it will start executing this line, correct?
yes.
But main method it will, after that what it will do, it will try to execute M1, correct?
Yes.
Okay, here let me write here M1. I think Ekramul, you also, it will be useful for you also whenever you are looking outside, right? So you will get this is the standard questions basically, list to stack, I mean data structures kind of thing.
Right.
This is the standard questions for interview basically. In a real time, it is very rare to use it, but whatever programming, whatever, I mean, a list, collections we are using, right? So internally they are using these concepts, but in a real time, we will not care what concept they are using. But back end side, internally we are using so many concepts.
Okay.
Okay, now if you see this one, right? So
Yeah.
when I will start executing, which method will try to execute first?
The first.
Yes, first main method it will start executing, correct?
Yeah.
Okay, then what will happen, it will create a stack. It will create stack. Okay.
Yeah.
So inside the stack, what it will do, okay, first it will create a stack and it will try to load main method, correct?
Yeah.
One box, first box. Okay, after from main method, you will start executing a particular portion. You will execute this line, correct? Line number 6.
Yes.
After that, what it will execute?
M1.
M1. So M1 will come into the stack. Okay, now, so from M1 I am trying to call M2. From M2 I am trying to call M3, correct?
Yeah.
Now come here. Oh, sorry, close it out. Okay. Now first main method will be called. From main method I am trying to call
M1.
M1, correct? So M1 will come into the picture. Okay.
Yeah.
Now from M1 I am trying to call
M2.
M2. Okay, M1 will be come into the picture. From M2 I am trying to call
M3.
M3, correct?
Yeah.
Okay. When it will start executing, right, first what it will do. So here let me add here start. So first it will, I'm displaying as a start. So M1 starting, and the last line is M1, and the similar way this is just for our understanding purpose. I'm adding this sysouts basically, where it started, where it's ended, when which method is started, when, and when which method got ended, just to understand for our purpose. Okay. So if when we start executing, now first main method will be loaded into the stack. From main method it will load M1, M1 to M2, M2 to M3, correct?
Right.
Now when it will so this is the method stack. Now we have to remove means we have to complete each method execution, correct?
Right.
So first whenever it is trying to complete, right, so first what it will do, it will try to complete first M3.
Yes.
M3 you will see first 100% execution. After that you will see M2, M1. After that M you will see main
Yeah.
method. So but when it's trying to load main method, from main method we are calling M1, M1 to M2, M2 to M3 we are calling. But when we are trying to execute it, this is the order. So how can we say like that? So let me M1, this is M1, M2, M3 is the last one. So I need to call from here M3. Okay, now let me execute it. We'll see these results. First M1, M1 to M2, M2 to M3, correct? M1, M2, sorry, here M3, M3, this is M2, correct? M2, okay. So now let me run it. Yes. Now if you see this one, right? First, which method it is loaded?
Main.
Main method, but it's not completed main method, correct? Just it
Yeah.
is loaded.
Yeah.
After that, which method it got loaded?
M1.
M1. After that, M2 it is loaded. After that, M3 is loaded, correct?
Yeah.
This is loading part.
Yeah.
And when it is trying to execute means it should complete everything, correct?
Yeah.
And if you see the last two statements, M1 is started, M2 is ended, meaning M3 is completed 100%, correct?
Yeah.
So execution part. So first it is trying to, which one is trying to complete? M3, correct?
Right.
After that you will see M2 end. M2 end means M2 method is completed,
Completed.
correct? So
Yeah.
M2 is completed. After that, which method it will try to complete? M1.
Yeah.
You see this?
Yeah.
At the last, which one is trying to complete?
Main.
Main method. So meaning Java programming language or JVM will use stack. When
Okay.
I was explaining JVM, right? So I explained you, right? Stack.
Yes.
So this is another example. JVM will also use stack, and operating system also will use stack.
Okay.
So all these things, whatever we discussed so far theoretically, right?
Yes.
We can able to write program, and we can able to save the data in this order, and we can able to retrieve the data in that order. This is just this all these things, right? Whatever we are discussing so far, this is just to process the data.
Yes.
So why we are using this kind of data structures? This is just to use, I mean just to process the data.
Okay.
Okay, now I explained you queue, right?
Yes. Q.
Another, there is another queue is called like a priority queue.
Priority. Yes.
Priority queue meaning, so whenever you are adding elements, right, so you can give the priority. So
Yes.
normal queue, what it will do, it will go equal to everyone, equal priority, I can say, correct?
Ah.
Whoever is coming first, they will serve first, correct?
Yeah.
But whereas in case of priority queue, so whenever you are adding elements, you can able to give the priority also. So
Yeah.
the execution will be started based on the priority of elements.
Right.
Like if you see, right, if you go for any of the uh, services, so sometimes they will give high priority for VIPs, correct?
Right.
So VIPs will be served first. After that, normal people will be served first. That is called priority, correct?
Right.
So in the similar way, in case of queue also, we have another queue called priority queue.
Oh.
So priority queue, what is the difference between normal queue and priority queue is, so priority queue, whenever you are trying to add element, so we have to add priority also. So the execution will be started, execution will be, will be based on the priority of the element.
Very well.
Okay, that is priority queue. So first what we discussed, list.
List.
So basically in list we discussed double linked list, correct?
Yes.
But we have another concept called single linked list. I didn't explain, I will explain you later. After that I explained you queue.
Q.
In
Yes.
queue we have like a normal queue and
Priority.
priority queue, priority
Yes.
queue.
Yep.
Okay, and third one we explained stack.
Yes.
So this stack, there is no there is no that many stacks. It's only one way to insert and one way to getting out.
Okay.
Okay. Now priority queue, normal queue, priority queue, stack. Yeah, single linked list. Sorry, double linked list. You understood, right? Like it
Yes.
is having three nodes. Sorry, each node is having three portions like this. So this is called as a double linked list.
Yeah.
Okay, if you know the first node, then you can able to go to the next node, and from that you can able to go to the last node. In the similar way, you can come back, right?
Right.
Correct?
Yeah.
Meaning you can say, like if you see the train boxes, so you can able to go from last to first, first to last, correct? All are interconnected, correct?
Right.
Okay. Now another example is, if you see some of the ways, meaning roads, so you will see arrow like this. You can go this way,
Yeah.
marked, correct? Meaning
Yeah.
you can go straight, but you should not come back.
Yes.
You will see some kind of traffic rules, right?
Right. Right.
So you can go straight, but you should not come back.
Right.
So way is there, but they're not allowing, correct?
Yep.
So this is called single linked list, and you can go back and you can come back. So train example is, some place you will see this symbol. It's very rare, basically, correct? They will not give this kind of symbol. Why? Because if you can go straight, if you can come back, meaning in that case they will not display any symbols, correct?
Yeah.
So if you can go straight, if you should not come back, in that case they will put this kind of symbols, correct?
Yeah.
So train is an example for a double linked list. So why
Yes.
I'm telling this train traffic signal, right? So you can able to remember forever, correct?
Yes. Yes.
So if you talk like that, right, you will never forget,
Right.
correct? So that's what I'm telling this, I mean, kind of example. Okay, now the single linked list example is, let me take a new thing. Yes, so double linked list means you can able to go front and back, correct?
Yes.
So
Yes.
meaning you can go this way, you can go this way, and you can come back.
Right.
So this is called double linked list.
Right.
Single linked list, what it mean? It is having only two portions.
Okay.
So one is having data
Yes.
and another is having next element memory location.
Got it.
So data, next element memory location. Data, next element memory location. Correct?
Oh, yeah.
So if you are here, you can able to go come to this location. Why? Because you know this, you are having this address, correct?
Yes.
So if you know from me here, you can able to go back. But if you know this one, but you cannot go back from here. Why? Because you don't know the previous node location, correct?
Right. Yes.
So you can able to navigate from left to right only.
Left or right only, not backward.
Yes, it's not backward. Okay, this example is we are using iterator in list, right? Collections, we are using iterator, correct?
Yes.
So for iterator, right, you can able to iterate the elements from starting to ending,
Ending.
correct? So there is another, but you are not able to come back. If you are trying to come back, right, it will not allow you.
Yes.
So there is another iterator is there. Uh, Java collections, right? I forgot that name basically. So we can able to go back and forth. Yes, this is the one. Yes. So if you use iterator, right, what will happen? So you can able to iterate the elements from starting to ending.
Yes.
Okay. So whereas if you're iterating elements by using enumeration, right? So not enumeration, list iterator. Okay. Okay. So if you see somewhere the difference between iterator and list iterator is, so if you use iterator, you can able to I mean, you can able to I mean, navigate the elements from starting to ending, correct? Like this.
Yeah.
So till this is the last node. So you can come back till here. Okay.
Yes.
But you should not go back. So it will not allow you.
Right.
So you are not able to come back. You are not able to read the elements from last to first. You can able to read the elements from first to last only.
Yes.
So iterator is using single list concept.
Yes.
Okay. And I said another example called list iterator. So if you see travels direction. So the list iterator allows programmer to iterate the list objects in both the directions. Meaning
Right.
you can go back to front
Mhm.
and front to back.
Yeah.
List iterator. But whereas iterator, you see the second one, iterator can use iterate the list map elements one direction, only
All right.
forward.
Yes.
So these two are examples for single list and double list examples.
Right.
Iterator, by using iterator, you can able to iterate the elements from starting to ending only. But whereas list iterator, if you use it, you can able to iterate the elements from starting to ending or ending to starting.
Right.
So you can go from here to here and anywhere you can able to travel. So this is
Mona.
a, yeah,
Okay, just a quick question on that.
yeah,
So, for instance, if I wanted to iterate from 1 to 100, right?
uh-huh, uh-huh,
That's a one-way direction, right? Going
correct,
forward.
correct.
So now I wanted to come back from 100 to 1. So it's
Yes.
going backward, right?
Yes, correct. Yes.
So is considered to be least iterator, right?
Yes, correct. List iterator will have that facility, so you can able to come back.
Oh, okay. So I can
See,
go forward and I can
yes,
come back.
some scenarios, right, they will give list of elements and they will ask you, they had given some 100 numbers. Okay, they will ask you, just tell me when 10 got added from the first time, what is the position of the 10 added position. Then you have to iterate, right, from starting to ending, correct? So they will
Right.
ask, they will give bunch of numbers. So I added 100 elements. Can you please tell me when 10 got added, what is the number, token number? So then we need to find out, correct? So first one, what is the first element number? Second location element value, correct? Each element we have to read, correct?
Right.
Each location we need to read it, the value. So then we can say 10 got added at the position of 20. Position means location. 10
Right.
element was 10 value is there at position number 20, correct? 10 is a value, the location is 20. So like that we need to, and the similar way they will ask, can you please tell me when the last time 10 was added? Then we have to come back, correct?
Right.
So
From the
they will
comeback.
ask when recently added, when it was added the last time. So in that case you need to back and forth, you have to travel it, correct?
Right.
When recently added, when it was added in the last. So this is the real-time example for list and list iterator, or example for single linked list and double linked list.
Yep.
So backend side they will use this concept. Single linked list, double linked list, queue, stack, these are the major 90% of the data structures.
Okay, yeah. I
So
think we are disconnecting in a minute, no? Less than a minute.
yes, fine, we will connect again, fine, no problem. Yeah.
No.
Yeah. So these are the basic, and also they will ask, right? I don't know whether they might have told you or not. This is data structures, and they will ask algorithms. Algorithms. Algorithms means one simple example. I don't know whether they might have asked or not. They will give a list of elements.
Okay.
They will give one list, and inside that they will add some random numbers. They will ask you to, can you please sort the elements in a sorting order? Can you please sort the elements in a descending order, ascending order?
Then I have to go for the tree set and then
Yes,
adding
correct. Yeah. So
complete.
there is a number of ways to do this same work, but what is the best way?
Oh,
Correct.
yeah.
So say for instance, when I'm traveling from India to Canada, right? So I can go in a different way. First, I went to Abu Dhabi, from Abu Dhabi to Canada.
Yeah.
Second time I went to Frankfurt. From there I went to Canada. So
Right.
starting point and ending point is same, but the path is different. Correct.
Yes.
Right.
Sometime I'm going to Frankfurt, from Frankfurt